Hello, welcome to Chemistry 111. Sorry we had this massive disaster earlier. I fixed it all by restarting the computer. We didn't have that time. So let's just go ahead and move along to going through the notes. It shouldn't take too long. We're going through the basics. The last topic we really have to cover is dimensional analysis. The basic idea here of how do we convert one unit to another unit. We're going to use some math. We're going to use unit setup, but it's basically I don't need to know any given equation if I know what units I have and what units I need. I can cancel out. I can combine together. It's going to set up how we multiply them all out. It's basically referred to as the railroad method, and that we can set up railroad tracks and set up so that units either combine together or cancel out to get what we need. If I know the area is in units of meters squared, and I have a length in meters and a width in meters, I know in order to get that, I need length times width, because meters times meters gives me meters squared. If I know I need a density in grams per mil, and I have 5 grams, and I have 1.85 mils, I need to divide grams by mils so that grams carry through in the numerator and mils carry through in the denominator to give us grams per mil, as we see here. The basic concept here is that just like numbers, units will combine together, multiply together, cancel out, whatever you may do. When I multiply 2 units, it's the same as multiplying 2 numbers. If I divide by 2 units, it's the same as dividing by 2 numbers. If 2 units of the same type are on the opposite sides of numerator denominator, they'll cancel out. Just like if I took 2 and divide by 2, they cancel out to give you 1. If 2 units are on the same side, they will combine together. So like grams times grams would be grams squared. Same way as 2 times 2 would be 2 squared. And any unit that is not canceled out will be carried through to the units on the final answer. We can do things just like that. Idea: if my corky weighs 34 pounds, how many kilograms would that be? I need the conversion of pounds to kilograms, but do I multiply by pounds or do I multiply by kilograms to get the final unit? Well, if I set this up, 34 pounds over 1, I multiply by 0.454 kilograms per 1 pound. I have pound on top and pound on the bottom of numerator denominator. The pounds cancel out, and I'm left with only units of kilograms. So I can multiply everything on the numerator, multiply everything on the denominator, do that division. Now, if I had switched the ratio and said divided by 0.454, I would have 2 pounds on top and a kilogram on bottom. Nothing cancels out, and we'll have pounds squared per kilogram, which is a unit that does not make sense mathematically for us. So if we set this up right, the units should always work out. Now, we're going to take a problem-solving approach to all of these problems. I'm going to take this approach, and between this slide and the next slide, this is how I try to set up almost all of my problems. You work it this way, you will be a much better case if you just try to wing it. Now, I'm not saying you can't wing it. I'm not saying you're not smart enough to wing it. You could probably do it. But a systematic approach, make sure you don't miss any obvious goofs. The first step I always try to take is determine what information is given, what are the units I'm looking for. So where I start with, where I end. And I can draw the path from start to finish, just like a Google Maps can. You put this is where I start, this is where I want to go, and it'll direct you there. On that path going from start to finish, I need to determine what relationships we need? What conversions do we need? What do we have to cancel out? Do I have to convert this unit to the next? How do we leapfrog from here to there? Next, I'm going to actually set up the problem and work it out. Show all the units. Try not to be lazy, cut corners, so that I can follow the work clearly and know I'm doing it right. And if you do that and I can see your work, that's going to help us all, where I know, oh, you have all the work right. You just must have punched something in the calculator wrong, as opposed to, who knows, magic. You're wrong. Now, this last step is something we'll try to do, but it's not something we might do right away. It's one of the harder things to actually accomplish. Check your answer. Rationalize your answer. Does this make sense? Some of them, it becomes really obvious whether this makes sense or not. You can look at the magnitude. If I'm dividing by 1,000 and I'm divided by a factor of a big number by a small number, I should get an even bigger number. If I divide a small number by a big number, I should get an even smaller number. It's one of those things that you check to make sure you didn't make any calculator errors. If you know dividing a big number by a big number, I should get a smaller number, and you get a bigger number, you might be able to figure out what you screwed up. But it might take us a while to get to that point. Okay. It's loading now. But what am I going to do specifically for each problem? Once I've determined all my values, I'm going to start by writing down my given value with units over 1. So usually one of the first numbers given over 1. I'm going to multiply by whatever conversion factors that cancels it out the given units and gives us the desired units. If I have to do this more than once, I try to plan it out so I don't go down any dead ends. Like if I have yards, I go yards to feet, feet to inches, inches to centimeter. If I have miles, I don't need to go to yards. I could go miles to feet, feet to inches, inches to centimeters. I don't need to go miles to feet to yards back and then go, oh, I don't know what the next step is. So I try to plan it out so each one cancels the last and gets me closer to my goal. Now, if you're given a ratio like miles per hour, you may have to do a conversion of both the top unit and the bottom unit. So I would have to turn miles to feet, and I might have to turn hours to minutes or seconds. So you'd have to do each of those conversions separately. Finally, one thing to note is if you have a square or cubed unit, you may have to do a conversion more than once, because an inches to feet conversion only converts one of those feet squared. And so you'd have to do it twice. Essentially, there's 144 inches squared in a foot squared, which is 12 by 12, by the way. So let's actually look at some of these problems. We have right here 5 mils, 2 nanoliters. We have to do that conversion. 10 yards to centimeters. 30 millimeters of mercury to torr. 5 centimeters cubed to inches cubed. Looking at that, we'll try to do just those. So with that in mind, I know these conversions pretty well, but I'll start with 5 milliliters. I'm going to go a roundabout way. You could probably jump straight from milliliters to nanoliters, but I'm going to go. So there is 1,000 milliliters in 1 liter. That's one conversion I know. So there's the first railroad tie. There's the second one. That cancels my milliliters and gives me a liter. And in 1 liter, there is 1 billion nanoliters. So not 1,000, That's a milliliter. Not a million, that's a microliter. But a billion nanoliters, or 10 to the ninth nanoliters in 1 liter. Now, liters and liters cancel out. We're left with milliliters and milliliters cancel out. So we're left with nanoliters. So 5 times a billion is 5 billion. 5 billion divided by 1,000 leaves us with 5 million nanoliters in 5 mils. The next one, 10 yards over 1. You could go from yards to meters to centimeters, but I don't know that conversion. I do know the inches to centimeters, and so that's where I'm going to go. So in 1 yard, there is 3 feet. Because I started with yards over 1, I'm going to go yards over 1, yards on bottom. In 1 foot, there is 12 inches. I'm going to cancel that one next. And finally, in 1 inch, this is the one I conveniently know, but would be given to you on a test, 2.54 centimeters. There's exactly 2.54 centimeters in 1 inch. So all we have to do is 10 times 3 times 12 times 2.54. A 914. 914.4. Okay, now technically, because this is 2 sig figs, you would really want to say 910 centimeters. We'll not worry about that right now. 30 millimeters of mercury. This is a unit of pressure. Give you that there is 760 millimeters of mercury in 1 atmosphere. In 1 atmosphere, there's also 760 torr. If you're clever, you might be able to go, oh, okay, units cancel out. I have 760 here, 760 there. 760 divided by 760 is 1. So we have 30 millimeters of mercury is equal to 30 torr. That is because millimeters of mercury were the original units used to measure a simple barometer. It was invented by Torricelli, and this unit was later named after him in his honor. So a millimeter of mercury is equal to a torr. Last one, 5.0 centimeters cubed. Little focus. So over 1. I'm going to go ahead and wait. So there's 2.54 centimeters in 1 inch. I have to do that 3 times because it's centimeters cubed to inches cubed. Each conversion only cancels 1 of those guys. That goes 2. That goes 1. That goes all the way gone. Inches, inches, inches. You have inches cubed. 4 root 3. So 0.305, but rounding at 3.5 inches. So 0.31 inches cubed. Okay, that in mind. that in mind. Walk our way through that. All that math is worked out for us. Now, the last thing we'll have to worry about is density and temperature. The only reason I give these is because this is some of the math that we'll have to do for this chapter. We'll be doing this in lab, especially looking at density and temperature. Density is a ratio of mass to volume. Remember, it's an intrinsic property that doesn't depend on the amount of matter. But one of the cool things about this is that each density for a substance is chemically unique. Now, some of them may be very similar to each other, but they are all, in fact, different. And so if you were to measure the density of lead versus iron, you would be able to tell the difference. If you measured it versus aluminum, you could easily tell the difference. And if we have dimensional analysis, we can solve any of the three variables given in the equation. Typically, we use density equals mass over volume. But if we're solving for mass, we can do density times volume. Or if we're solving for volume, it's mass over density. Basically, by canceling out units, we get a new unit. And we'll do some of that in the next slide. Now, the temperature. Temperature is the physical measurement of heat flow to and from an object. The SI unit is actually Kelvin. We have not really probably seen Kelvin before. Kelvin is a conversion off of Celsius, but it's special. Celsius plus 273 equals Kelvin. So that if you have 0 degrees Celsius, you have 273 Kelvin. Why this is special is because Celsius is only based off water. Kelvin can go through water. Kelvin has an absolute 0. You cannot get lower than. So whenever we're doing math with temperature, you can never divide by 0, and you can never have a negative number. While Celsius, you'll have a lot of negatives, and so we're trying to avoid that. Fahrenheit, we can convert from Celsius to Fahrenheit based on the equation Celsius equals 5 over 9 times Fahrenheit minus 32 in parentheses. One easy way to remember whether the Fahrenheit minus 32 goes in or out of the parentheses is freezing point of water is 32 Fahrenheit. 32 minus 32 is 0 times 5 over 9. So 0 times 5 over 9 is still 0. If otherwise, you would have a really messed up thing. You wouldn't be able to figure it out. 32 times 5 over 9 minus 32 is a little bit messier. But we're going to do some of that math. So, how much volume with 13 grams of aluminum take 13 grams of aluminum with a density of 2.7 grams per mil take up? We're going to look at 32 mils of 0.93 grams per mil density olive oil. How much would that weigh? Finally, at what temperature Fahrenheit would 150 Kelvin occur? So looking at those. So start up here with we're given 13 grams per mil per 1 of aluminum. Now, if I need mils as the final step, I need grams gone and I need mils on top. So I'm going to take and divide by 2.7 grams in 1 mil. By doing that, grams and grams cancel out. And we're left with divided by 2.7, 13 divided by 2.7, which gives you 4.8 mils. I'm rounding it to 2 sig figs because I have 2 sig figs, 2 sig figs. Next one, I have 32 mils starting with, and I want to know what's the mass. So if I want grams on top, I need to cancel out mils. So the density is 0.93 grams per 1 mil. Mils and mils cancel, and you get, I've already done this one. Remember, 32 times 0.93 gives you 29.76, which rounds to 30 grams. The last one. What temperature in Fahrenheit would 150 Kelvin occur? Celsius plus 273 equals Kelvin. And I have Celsius equals 5/9 F minus 32. So I have to work our way backwards. So Kelvin, 150 minus 273 is going to give our Celsius. So 150 minus 273 is negative 123. 23. Working our way backwards. Fahrenheit must equal 9/5 Celsius plus 32. So 9/5 times negative 123, all that plus 32, times 9/5 plus 32 means we have a temperature of negative 189. 189. Okay. And as you see right here, click on the next. Can round about 189. So, with that in mind, that is all we have on this chapter. We'll look at a little bit more. We'll look at some of the homework on Wednesday, as next Monday is Martin Luther King Day. So thank you for your time. Sorry for the inconvenience. See you on Wednesday.